Okay, so here's a slightly harder trigonometric equation to solve. Okay, so what's going on here? We have three sine terms on the left, and we have this sort of cosine squared term, which is looking sort of out of place with the rest of the equation. You can try a couple of things here, but really it just comes down to a problem that you need to have seen something similar like this before in order to solve it, right? The trick we're going to use is we're going to employ the Pythagorean trig identity here. So we know that sine squared plus cos squared x is equivalent to 1. And I'm going to use this to actually eliminate the cos squared terms and get it all in terms of sine, right? So I can actually use this form of the identity where I subtract the sine over to this side. And I'm going to plug that in for the cos term there, okay? So the right hand side becomes 9 brackets 1 minus sine squared x, okay? Which is 9 minus 9 sine squared x. Now if I move that 9 sine squared x over, on the left hand side I'm going to have 12 sine squared x. Then I'm going to add sine x. Then notice we have a 9 now, so I need to subtract that 9 from both sides, and I'll get minus 1 equals 0. So that's a quadratic in sine we're left with to solve. And the question is, how do we solve this? Well, I'm just going to go ahead and stick it into the quadratic equation because that's what I would like to do. Actually, wait, no, I think I've spotted the factorization. Yeah. Okay, and we can see that the minus 1, so yeah, this would need to be a plus 1, and the minus 1 would need to go there, equals 0, right? So, you know, all of this is equal to 0. I'll put it over here. So that's correct. Now we're going to go and deduce that sine x is 1/4, or sine x is minus 1/3. Now it depends what range we're asked to solve it in. I forgot to give that at the start. Let's suppose that we are asked to solve it in the range, you know, usually it's this, right? Okay, so if we're doing it in that range, it's just a simple case of, again, looking at our, well, some people use cast diagrams, but the way I recommend you do it is just sketch the wave, okay? So avoid cast diagrams. Just remember what the graph of sine looks like and use symmetry. That's the way I like to teach it. So really, sine of 1/4, you're looking for that line where 1/4 is. You know that arc sine of 1/4 is going to give you this principal value of, I'm just going to guess, 15 degrees or something like that here. This point is 180, and you know that this other intersection is going to be 15 away from 180 that way, right? So arc sine of 1/4, you're going to take that away from 180 to get the other answer. So that'll give you 2. If it was 15, it would be like 165, for example, right? The next one, you're going to take arc sine of minus 1/3. The line minus 1/3 is going to cross sine around about here. So you're going to get our one answer. Again, I don't really know what that's going to be. I'm going to guess it's, let's go with 200 degrees. Right, let's pretend that arc sine of minus 1/3 is about 200 degrees. How would I get the other solution? Well, it's simply, again, I use symmetry, right? The distance between 180 and whatever I had, let's say 200, so that's 20 degrees there. That has to be an equal distance over here as well, right? Because of the symmetry of the graph. The graph is symmetrical about that 270 degree point, and I know that the line, you know, minus 1/3, that's exactly where my solution would be. That's you know, the intersection of this graph is asking the question, when is sine of x equal to minus 1/3? And your calculator will give you this value, or perhaps, actually no, because of the way arc sine is defined, sorry, it's going to give you this value over here, isn't it? Yeah, so you're going to get out, you know, whatever way your calculator is set up. Well, of course, you're going to get out this part. That's going to be, I guess, like minus 20 degrees, right? You want to add 360 to that to get into this range. Okay, so that would give you that point. And then again, you'll look at the distance between it and 360 and then work out how to get the other point. Okay, I hope that's clear how to go about that. If not, just leave me a comment and I'll try and explain it in more detail, or I'll just redo the video. But essentially, you're trying to use symmetry to get the solutions out. So and yeah, so that's just a more complicated version of those problems. When you have the cos squared term there, you just want to change that for a sine squared by using the Pythagorean trig identity there.